All right, so welcome to this demo. It's actually the third demo that I run on MediaPipe. And if you already attended to one of my previous demos on MediaPipe, you know that MediaPipe is a library that contains a lot of yeah, let me check that. Yeah, it contains a lot of models that are already trained, and you can use very easily on your computer. So you can just go to MediaPipe and just take a look at the solutions that they provide. For example, you can check face detection. This is going to work on an object detection model, and it will tell you where different faces are in the image. You can also take a look at the face mesh, which is the model that I ran last week, or the hands one that I ran 2 weeks ago. This week, and this is going to be the last demo on MediaPipe that I will run. This week we are going to use the pose one, and in this case, yeah, it will help us just to detect different parts of our body, like the shoulders, the wrist, the elbows, different parts that I will show you now how to do because it's super easy. And let's take a look at the notebook actually. Instead of just going through the documentation, let me open the notebook. In this case, there we go. Cool. All right. Okay, so yeah, this model will basically detect different landmarks. You can see here that you can detect the elbow, the shoulder, the hips, the eyes, the nose, and you don't have to train it before using it because it's already trained. The only thing that you have to do is run the model and enjoy it. Let's see how it works.
I don't think you're sharing the screen unless it's just on my side that you're not sharing it.
Yes, that's thank you.
No worries.
Oh my god. All right, sorry. Once again. All right, let me show you. Cool. So I was saying that you can just get access to the documentation on MediaPipe. Just Google in MediaPipe, click in the first link, and take a look at solutions. So here, for example, you can see a library that will help you, or simply will detect where different faces are on the image. Or you can detect different landmarks in your face, for example, using this solution called face mesh that I ran the last week. But as I said, this week we are going to run this one, the body position one. Okay, so instead of going through the documentation, I just prepare a notebook that will help us with all of this. So this model will basically detect where my elbow, my eyes, my mouth, my hands, my hips are. So all this code that you see here might look a little bit intimidating, but don't worry, because if you scroll down in the documentation, you can see that here. Basically, you can just copy paste it. And as I said, you don't have to worry about training the model. The only thing that you have to do is copy that, paste it here, and enjoy the output. So let me stop my camera and zoom. And now if I run that, here we are. So it's, sorry. Yeah. So it's detecting now my eyes, different parts of my body. But if just give me a second, I'm gonna remove this green screen because otherwise I won't be able to move back. And sorry. Okay. So now that I'm standing up, you can see that it's detecting different parts of my body, like my shoulders, my hips, my elbows, and all of that. All of that you can see here on this image here, where it's basically showing you different landmarks that are going to be detected. Okay, so very easy, right? You don't have to worry about anything. And actually, if you're on the rock, paper, scissors and you want to use this library, feel free to do so, because it's it will be a much more accurate model. In this case, if you want to use that, by the way, don't use the body position, go with the hands position. In this case, it will, oh, sorry, I opened that in a new tab. So yeah, it will detect different landmarks on your hand. So might be more accurate if you want to show rock, paper, or scissors to the camera. But yeah, that's up to you. If you don't want to use it, don't worry. It's completely fine. Teachable machine is the reason I was telling you about teachable machine is because it might be a little bit easier to get access to basically the output of the model. In this case, you have to program it a little bit, but it's not really difficult. Okay, so once we know how to do that, there's a couple of things that I want to show you before moving on, because what we are going to do with this will be creating a personal trainer. I'm gonna try to make some squats and let's see if that works. And well, I think I'm not really an expert. Usually when you make a squat, your the line connecting your ankle and the line connecting the ankle and the knee has to form a 90 degrees with a line connecting your hips and your knee, or 90 degrees or less. And yeah, your knee shouldn't be in front of your toes, something like that. But let's keep it simple. Let's just assume that they have to form a 90 degrees angle. So before moving on to that point, we need to calculate the angle, the angle that two different lines are forming. For example, actually not. There we go. All right, so for example, if I'm using let's say I want to calculate the angle the angle between the line connecting my wrist and my elbow and the line connecting my shoulder and the same elbow. Yeah, we can do that by using this library, for example. So let's see how to do that. Before I explain that, just let me show you that if I take a look at the landmarks, in this case, let's say that I want to take a look at the landmark on the left knee. We need to get access to that by indexing this result that we obtained from the predictions of the model. Then we have to access to the landmarks, and finally we have to give an attribute to that landmark. So if we go, for example, if we want to take a look at the left elbow, in this case we will need to go to the to index 13. So something like that. And let's take a look at left elbow, what left elbow look like. Yeah, it's going to be basically giving us the coordinate, the X, Y, and Z coordinate of my left elbow. Okay, so now that we know that, let's see how to calculate the angle between, for example, the line connecting 14 and 16 and the line connecting 14 and 12. I'm just gonna explain to you a little bit on maths. Probably you're familiar with this, but the angle can be calculated using these equations. So we know that the cosine of an angle is going to be, well, I'm not gonna dive deep into this. Basically, you can always check out those equations, but here what I'm basically doing is defining a function that is going to take 3 points and is going to calculate the angle formed by the line connecting those 3 points. Okay, so basically that's it. As I said, I don't want to dive deeper into it because this is not a math class. You can always check this. You can always check these equations. And finally here, what we are going to do is calculate the angle between joints. So I'm going to define a function that is going to help us simply by giving it the results of the prediction of a model and 3 different joints in our body. Is going to calculate the angle between the lines connecting those 3 joints. In this case, well, sorry, I'm just saying left elbow because that was the thing that I was using, but I'm just going to use something a little bit different instead of middle. Oh, sorry, left elbow, middle. like that. In this case, instead of left shoulder, I'm gonna change it for higher, and instead of left wrist, I'm gonna change it for lower. Cool. So now the function is now the function is defined. So let's see, for example, if I want to calculate the angle between my shoulder, my shoulder, my elbow, and my wrist. Let's see how that. Let's see what that will look like. So I'm gonna call the function. I'm gonna use results, the same results that we obtain here. Where is it? Yeah, results has been calculated earlier when I run the model before, so that variable is still stored in this notebook. So I'm gonna use results, and I'm gonna say that the middle joint is going to be, it's going to be this one. I'm not gonna complicate things anymore. Just gonna do this. So yeah, the middle joint is going to be the elbow, the higher joint is going to be the shoulder, and the lower joint is going to be the wrist. So let's see, yeah, they form an angle of 55 degrees. Well, it's not telling us a lot, but let's see that in action. So now instead of going with the knee, I'm going to go with the middle one will be the elbow, the higher one will be the shoulder, and the lower one will be the wrist. Let's see what happens. Oh, sorry, I need to interrupt. Sorry, I need to do that. And now, oh, sorry. I know why it's not working. It's because I'm opening the camera on Zoom. So I'm gonna stop the video on Zoom. And now, okay. So let's see the angle that's formed between the three joints that I mentioned earlier. So you can see that more or less if I form a 90 degrees angle, yeah, it's working fine, right? More or less, yeah. Cool. All right, so as I said, this model will be trained, or sorry, we will be using this model or these predictions to see if I'm doing properly a squat. So let's try to code that. I'm gonna copy that, I'm gonna paste it here, and sorry, opening the camera again. Cool. So now we know that this angle is going to be the angle between three different joints. And in this case, let's see that if angle is, let's say, lower than 90 degrees, then print, I don't know, good job, something like that. Oh, well, actually, now that I'm using my elbow, shoulder, and wrist, let's go with an angle between 80 and 90, just to see if it works. Oh, sorry. Once again, stop video from Zoom. Interrupting here, and oh, sorry, I put 90 degrees. It should be 100. So if Chris, yeah, you can see that if it's in the range between 90 and 90 and 100, it's printing good job. Otherwise, it won't do anything. Cool. Okay, so one more thing that I wanted to do is okay, I'm not sure if we will have time for that, because I will run another demo on how to use this personal trainer with an Arduino with something like this. Well, sorry, let me show my camera. Cool. So basically, if you have a device, small device like this, you can also use this with Python just to program different algorithms. In this case, yeah, it's basically showing a 2, which will count the number of repetitions. But in order to explain all of that, yeah, it will take a lot of time. So I will leave that for another demo. For now, what I'm going to do is I'm gonna stop the Zoom video because otherwise I would forget about it. And where was I? Where was I? Phew. Okay, so in this case, what I'm going to do is, when you're making a squat or when you're making some different positions while working out, usually you have to hold that position for a couple of seconds, or at least, let's say 5 seconds in this case. So let's go with, let's define a couple of flags. So flag good is going to be 0, and flag that is going to be 0. Something like that. Let's see if this works. So if the angle is between 80 and 100, yeah, I will increase this number by 1 for each iteration that I'm doing a good job. So let me do that. So flag good. It's going to increase by 1 at each iteration in which the angle is between that range. Otherwise, if I'm not holding that position, then well, actually, I don't need. Now that I think about it, I don't really need the flag bad. I'm just gonna say that flag good is set to 0 again. Cool. All right, that should do it. And now, if when we increase it, if let's say flag good reached, I don't know, let's say 20 iterations, we are going to print something like keep going, something like that. Let's see if it works. So I'm gonna hold this for, let's see. Yeah, keep going, nice. And if I remove that, oh, sorry, maybe I should print something in case I'm not holding the position. So I'm gonna print something like go back to the last position, something like that. Keep going, and now if I quit from that position, it will tell me to go back to the last position. So that's what I'm doing. Okay, looks like the logic is working more or less fine. So now it's basically taking 20 iterations to tell me to keep going. But instead of that, let's see. First, I'm gonna tell it to tell me to keep going. But then if we reach something like, actually, I want to ask you something now. I'm gonna print here just a little bit more, something like that, just a little bit more. All right, do you see any problem with this logic? Anyone?
Yeah, it's possible to trigger both conditions, or the second condition being met also meets the first condition.
Exactly. So yeah, will we ever see just a little bit more printed out?
No, because that has to be that's only happens if it's not greater than 20, which is impossible.
Yeah, exactly. So we have to change that, and also changing that. Cool. So if it's written down, all right, and finally, if so, I'm just gonna say 100 print good job, and I'm gonna add this with and it's equal to that. By the way, these are here at the with the keyword and. We'll just remove what we have printed out earlier. So the output is not cluttered with a lot of messages. Let's see. Oops. Yep. going, just a little bit more. Good job. Okay. Now let's refine this a little bit. Let's refine this a little bit. This should be removed as well. I'm gonna add some spaces. So anything that we print can just, all these white spaces are going to be on top of what we printed previously. So anything that we print will be just will be just occluded by those white spaces. It's telling me to go to the last position, basically keep going, just a little bit more, and good job, nice. So we can just go in like this many times as you want, and we're almost there. We're almost there. The only thing that we are missing is know how to do it with well, applying this for making squats, right? So let's do that. Instead of the elbow, now I'm going to detect the knee. Instead of the shoulder, I'm going to detect the hips. And instead of the wrist, I'm gonna detect the ankle. All right, it's not hips, it's hip. And oh, I need to destroy the window. There we go. Okay, so probably I will need to remove my headphones. I'm sorry if you will ask me something now, but yeah, I need to put my camera more or less like this, I guess. Let's take a look. Let's see if this works. Okay, now let's see how this works. Yeah, sorry, right now I have removed my headphones, my earphones. So if you're asking me something, I'm not going to be able to hear you. Let's see. Okay, so now it's detecting more or less my body. Let's see. Maybe I should move a bit. Oh, there we go. So if I go like this a little bit more. I mean. Yeah, there we go. Okay, this is ridiculous, but it's working. Just a little more. Yeah, good job. Oh shit. Shouldn't have worn my jeans now. That was exhausting. I need to do more. I should never skip leg day. Cool. All right, so I think that's it. I think we cover everything. The next day that if we run another demo on this, I will show you, instead of a little bit more visual way to do all of this. So let's see, is this the one that I wanted to show you? I think so. So this is the Arduino thing that I wanted to show you, and if I hold this between 80, 85, and 95 degrees, it will count the repetitions. So one, now the LEDs, are glowing up. And if I reach the third LED, it will count as one repetition. There we go. I'm getting tired. Well, never mind. I think you got the idea. Cool. So, is there any question before we call it a night?
Yeah. Is it tracking you? So it's just basing it off the image and its model of the body, but is it tracking you in a 3D sense at all, or is it just the 2D angle between the lines?
Oh yeah, that's a good question. I just kept it simple when I did all the angles. When I calculated all the angles, basically I just did a 2D, like a 2D map. But the model is actually tracking you in 3D. You can actually take a look at this. It's basically you like this. But in my case, I just try to keep it simple, just calculate the angle between two lines in a 2D map.
Okay, so it's capable of doing like 3D
yeah
stuff. Okay, cool.
Actually if you take a look, if we take a look at what was it, sorry, it was here, if we take a look here, you can also see that there is a Z coordinate, which is basically the depth. These values are normalized. They are basically with respect to the, well, they are normalized, I think, with respect to the camera position or something like that. I can't really remember, but you can see that these coordinates doesn't really make sense, but they make sense for the image. So, for example, if the image is 111, yeah, this means that my left elbow is at position 0.94 with respect to the width of the image, and this is a little bit out of the image, 1.37. That means that it's a little bit above the image. And this depth, to be honest, this depth, I'm not entirely sure what was what was it respect from, but yeah, it can also calculate the depth.
Wow, okay, cool, thank you.
Sure thing. Okay, so yeah, I hope you liked the demo. If you have any other question, just feel free to drop me a message through Slack. Well, if you have any additional question now, I can also answer it now.
I just have a quick one, Ivan. Where are these recordings, where can they be found, like, afterwards, so that I can look at them in my own time?
Yeah, sure. I will send you the link. Well, I usually send the link to the all announcement channel, but also they are public. So if you go to the Aircore YouTube channel, you will see these demos.
Okay, that's fine. Thank you for that.
Sure thing. Cool. Anything else, guys? Oh man, I'm tired. Seriously. Okay, now I'm gonna stop the recording now.